Welcome students. Welcome to the third lecture of module 3. This is under the components and hydraulic circuit design. We are discussing today that is a pressure reducer valve and a counterbalance valve. So in the last class we have discussed regarding the other three types of pressure control valves, that is pressure relief valve, sequencing valve, and that what are the puppet operated pressure control valve. Okay, so next we are going to study in here is the pressure reducer valve. Okay, so what is the difference between the pressure relief valve and pressure reducer valve? Okay, the pressure relief valve is nothing but it's going to be used to relieve the pressure. Okay, so the whatever the fluid is transmitted from the reservoir to the next unit, that is maybe the direction control valve. What happens, the pressure if the pressure is increases in the further process, so that can be relieved by using the pressure relief valve. So in here also, but in the pressure relief valve what happens, the complete liquid is going to be removed and it can be relieved. Okay, the pressure which is going to be developed, it can be relieved in the pressure relief valve. But if you come to the pressure reducer valve, the some amount of pressure is going to be reduced. So the regulated pressure is going to be maintained by using this pressure reducer valve. A pressure reducing valve is normally as open two-way valve that allows the system pressure fluid flow through its until the set pressure is reached downstream. So what happens, you just see this diagram. Okay, in this diagram what the line pressure, which is nothing but the liquid coming from the pump, which is having the pressure which is coming here and it is moving to the next, that is direction control valve or any other segment. So what happens, as the liquid moving through this, it is always open. Okay, this valve is always open, but pressure relief valve is always closed valve. So what happens, if the pressure develops in this whatever the line, the transmitting line, if the pressure develops in somewhere at the transmitting line, the pressure is going to be exerted on this spool. This is the spool which is present inside the valve. The spool is going to be lifted. Okay, the spool is going to be lifted up. By that, the some amount of liquid is going to be bypassed to the reservoir. Some amount of liquid is going to be bypassed to the reservoir. By that, the regulated pressure is going to be maintained in this valve. So that is called as a pressure reducer valve. So in this it then shifts to total flow into the branch. The same thing I have explained in here. The some amount of liquid is going to be transmitted to the bypassed to the reservoir. By that, the pressure regulation is going to be maintained. So pressure reducer valve is mainly used to regulate the pressure of the hydraulic system. So you can see this small circuit. In here the liquid is coming from the pump, then it is going to be transmitted to the direction control valve, then it is transmitted to the actuators. Okay, so in here similarly the liquid is transmitted in here through the pressure reducing valve. Okay, it is normally transmitted, but in here it is in the another section, the same source is going to be connected to the two actuators, one actuator and second actuator. So this liquid is going to be transmitted through the pressure reducing valve and through the next is the direction control valve to the next actuator. So what the pressure reducer valve going to do? The liquid comes here, it is always open, so the liquid is transmitted to the direction control valve. Somewhere the pressure is develops out here and it will again affect on this whatever the direction control valve. This pressure, again the lines are going to be in a pressure, it is going to sense the pressure in here. So the pressure line which is dashed line which is shown in here, it will sense the line and it will closes this whatever the opening from here to here. It will not completely closes, but it will slowly closes this wall and opens this tank port, and whatever the liquid is going here and the pressure will be relieved and reduced. So regulated pressure only allowed to pass through this whatever the next line. So like that the regulation of pressure is going to be maintained in the pressure reducer valve. So next is the counterbalance valve. This is the last valve in the pressure control valve. So the counterbalance wall is also called as holding wall. Okay, if you have any load, it should be holded for some amount, some movement. So that can be achieved by this counterbalance wall. The counterbalance wall is also called as holding wall, is used to prevent the weight from falling uncontrollably. Okay, if you just imagine a actuator is holding some weight. Okay, so that weight is moving downward with respect to the gravitational force. So the if we don't have this counterbalance wall, it suddenly falls and it affects on the actuator. Okay, so that can be avoided by using this counterbalance wall. How it is going to be avoided? So see this diagram. Okay, this is the diagram of counterbalance wall. And this is the adjustable knob to adjust the spring tension in here. So spring is tensioned to the spool. This is the spool which is connected here. So this will move to and fro. This is the check valve provided here, and the ports A to B. The liquid is always flowing from A to B through opening this whatever the check valve, and it will move to the next unit. But whenever the liquid coming back, okay, B to A, the liquid is transmitting back, then it should not open this check valve because it is one-way valve. So the liquid is going to be trapped here and it will pressurizes this spool. Okay, the spool is going to be shifted left side because of the pressure, and some amount of liquid is going to be transmitted to the A port. So this B to A movement is going to be hold that load by sudden falling. Okay, so the pressure is going to be set at here. At that pressure only the valve opens and whatever the liquid transmission between B to A takes place. So you can easily understand by this diagram. So in here the actuator is there which is holding some load. Okay, so this is the counterbalance valve. So as the liquid transmitted here, it will pressurize the piston, it will fall down. Okay, but the liquid which is trapped at here, it will transmit it through here, and it will make this counterbalance valve at some pressure. The pressure is going to be set to this counterbalance valve. It will not open suddenly. When the pressure is reached, the set pressure is reached, then only this valve opens slowly, and because of the slow movement, the slow downward movement of this weight takes place. Okay, so this is valve closed. When a valve opens like that, it is going to happen. So that pressure should be reached, then only this whatever the counterbalance valve opens and it will allow the flow. Okay, like that we have to we are going to use this whatever the counterbalance valve for to avoid the sudden falling of a load. Okay, so these are the different types. We have discussed earlier: pressure relief valve, sequence valve, pressure reducing valve, and counterbalance valve. These are the main 4 types. So these are the symbols of this whatever the pressure control valves. Okay, so in here the pressure relief valve is always closed valve. It is not always open. So always closed valve. The pressure is required to open this. When the line is having extra pressure, then only it opens and it will sends the pressure and it will transmit that liquid to the reservoir. So this is the symbol. Next, the sequence valve is nothing but it will transmit the liquid from one line to the pressure line to the another cylinder line. Okay, one cylinder line to the another cylinder line. It is also going to open only when the set pressure is reached. So it is also a always closed valve. Some amount of liquid, if the pressure is increases at here, then only the liquid is transmitted to the whatever the tank. Next, pressure reducer valve, as we discussed now, it is always open valve. Okay, it is going to be closes only when the high pressure is reaches at the actuator end. Actuator end, if it is having high pressure, then only it will opens and it will make the some amount of liquid to transmit to the reservoir and it will regulate the pressure. Okay, and next, counterbalance valve. In the counterbalance valve, it is also a always closed valve. It only opens when the pressure is increases and it will allow the slow downfall of that whatever the load. So like that, these are the symbols which are going to be used to represents the pressure control valve. Okay. Thank you, students. I think you have understood regarding the pressure control valve. There are 5 types we have discussed till now. Okay. If you have any doubts, you can contact me. Thank you.